Okay, here's a question where you need to solve each equation for y. Um, it's different than solve in the equations. If you're asked to solve these equations, the system of equations, then you'd have to find a value for x and for y that's true in both equations. But I think this question just says solve them for y, and then check. And you could check them on a graphing calculator if you wanted. Okay, so this first one, I need to get y by itself. So I'll do it a couple of different ways. I'll do this one way and do this one another way. One way that probably a lot of students would do is would say, okay, let's first get this y term together, or on one side, and move this one to the other side. So I'll do that. I'll leave the negative 1/2 y here, and then I'll take this 2/3 here, move it to the other side of the equal sign, make it negative 2/3 x, and then I still have a positive 3/2 there. Okay, so I'm pretty good, but I've got a y there, but I also have a negative 1/2 that I have to get rid of. Okay, to get rid of, alright, so I need to get rid of this negative 1/2. So to get rid of anything that's being multiplied by y there, let me change my color. So if I'm multiplying y by negative 1/2, to get rid of that, I'd multiply it by the reciprocal. So I'm going to take this side and multiply it by a negative 2 over 1. But if I do it on this side, I have to multiply everything over on that side. Let me just rewrite it. So I'll have negative 1/2 y equals negative 2/3 x, that's 2/3, plus 3/2. And so I'm going to take this side and multiply it by a negative 2 over 1. And I do that so I can get a positive 1 right there. Negative times negative cancels. 2 times 1/2 gives me a positive y. But if I multiply this side by negative 2, I got to take this other side and also multiply it by negative 2. Now that's the distributive property, so I need to multiply both things inside there. So on this side I'm left with a y, and then on this side it'll be negative 2 times negative 2/3. That would be a positive 4/3 x. Do you see that? Negative 2 times negative 2/3. So negative 2 times negative 2 would be a positive 4 over 3. No denominator here, I can assume it to be a 1. And negative 2 times 3/2 would be negative 6 over 2. So it would be negative 6 over 2. Oh, which I could simplify, right? So I have negative 4/3 x minus 3. So that's how you could solve that equation for y. Now on this side, you could do the exact same thing. But let me just show you another little trick that sometimes helps so you're not fighting with fractions the whole time. It's called the I hate fractions rule. And what you do is you multiply every term by the lowest common denominator. Between 4 and 2, the lowest common denominator would be 4. So I'm going to take this term, multiply it by 4, take this term, multiply it by 4, and take this term and multiply it by 4. When you wrote that out, you said 12. I was wondering if you meant 1/2, but it said 12, so I'm going with that. Anyway, 4 times 3/4 would just be a 3x. And then this would be 12 over 2, or plus 6y, equals 4 times 12 is 48. Now to solve for y, you don't have any fractions anymore, so it's nice. You're probably going to get fractions at the end, but at least for one step you don't have any. So I'm going to push the 3x to the other side and make it negative 3x, and I have a positive 48 there. Now to solve for y, I'm going to have to divide everything by 6. So I'll take that, and this, and divide them all by 6. So these would cancel, there'd be a y. This would be a negative, if you simplify it, negative 1/2 x. And 6 goes into 48 about 8 times. So now those two equations are solved for y. Now if you wanted to let's see. Yeah, I guess if you wanted to figure out the solution, well, I guess you can't figure out the solution for this because it has innumerable solutions. This is an equation of a line that would look something like, I don't know, something like that. And there'd be innumerable values of y and values of x that would solve this. Same thing over here. Now, if you wanted to solve the equation, now I could take those two equations there, and to solve it, I would have solved them up the top there, but now that I've solved them both for y, what I can do is I can take, if I'm solving the equations, in other words, like this line here would look something like this, something like that. To solve the equations, what you're looking for is a place where the two lines meet. So where they meet, that would be a specific x and a y value. And so if it's a specific x and y value, this y value and this y value would have to be the same at that point where the two lines crossed. So what you can do is you can say something like y, since y is equal to y, negative 4/3 x minus 3 must equal this part, negative 1/2 x plus 8. Okay, and then solve that. So I just have x's, I can solve. Easiest way to solve, multiply by a lowest common denominator. So I'll multiply this side by, I'll multiply everything by 6 because I have 3 and a 2 as my denominators. These ones are 1s. So multiply everything by 6. So if I multiply this by 6, I'm going to get negative 8x. This one by 6 would be negative 18. Equals this one by 6 would be negative 3x. This one by 6 would be 48. I hope you're okay. So what we did from there is we just times everything by 6. Okay, gather x's, gather the other stuff. So if I take the 8x over to this side and make it positive, it would be 5x. If I take the 48 over to the other side, it would be negative. So negative 18 minus another 48, would that be about 66? Minus 66. And then divide both sides by 5. I'm thinking that maybe that 12 up there should have been a half because the number didn't come out bang on. So this would be negative, I don't know, 13 and a fifth. You could probably just leave it like that. Then to solve for y, you'd plug this back in for x right there, solve this out to see what y comes out to. Okay, hopefully that helps you with that question. I wasn't positive what the question said. If it was solve the equations for y, this is where you would stop. If it said solve the system of equations, then you'd need to go a bit further than I did here and determine what y was as well. And to do that, you'd plug this in to the equation either here or there. Both of them should give you the same answer. Now if they say, once you find your x and your y, if they say check your answer by graphing, you could just put this on your graphing calculator. Put that, and then put this, and so you put that, this one is y1 say, and this one is y2 on your graphing calculator, and what you're looking for is where they cross, the point at which they cross. Okay, hopefully that is helping out.